Okay, when it comes to geometry, does anyone know what this is? If we were to think geometry. Any guesses, Tim?
Cartesian plane.
So this is the Cartesian plane, right? So we'll write that down, Cartesian plane. So how do we label a Cartesian plane? Is anyone who can tell me how a Cartesian plane is labeled?
If you were to do it on the y-axis, would be the horizontal line.
Mm-hmm.
I mean,
The vertical line,
The
yeah.
horizontal line would be the x-axis.
Okay. And then each one of these would have a number, right?
Yeah.
Now, by looking at this, what other geometric property do you see here? I wonder if I can use this to help me. Anything you notice about the Cartesian plane now? If I show you a protractor? Aaliyah? So you said right angles?
Yeah.
Where do you see a right angle?
In each corner.
Each corner? You mean here?
Yeah.
So this has a right angle here. I'm going to write this in pencil. So this has a right angle. And then you said each corner, so I'm assuming you mean this one?
Yeah.
This one?
Yeah.
And this one. Okay, great. So a right angle is what? How do we identify a right angle? What makes it a right angle? Irfan. So right angle, so this is all background knowledge that we have. A right angle is 90 degrees. So this angle right here, 90 degrees. These two combined would be how much? Ryan? Yeah, so this one's 90. These two combined, so if I went from here to here, that's 180. What about if I went from here all the way here? How many degrees would that be? Jada? It's 270 degrees. And what if I did this? If I went from here all the way around to here, how many degrees would that be? Full turn. 360 degrees. Great. So now, for the grade 7s, you need to identify it in degrees. But how many corners does the Cartesian plane have? How many corners does it have? This one's mostly for the grade 6s, Aaliyah? 4. So this is, and we don't call them corners anymore. This is now, each section has a unique name. It's called a quadrant. Okay. And this is quadrant number 1. This is quadrant number 2, number 3, number 4. So another name for 90 degrees, because there's 4 quadrants and you're using up 1, what else can we call a 90 degree turn?
A quarter.
This would be a quarter. So a 90 degree turn, this 90 degrees here, is also a quarter. So what would 180 degrees be? If 90 degrees is 1 quarter, because it uses 1 quadrant, 180 degrees uses 2 quadrants. What would the turn be, Ryan? Half. Why not 2 quarters? It could be 2 quarters, but we just say a half. We reduce the fractions, right? And then, for, oh, I put the wrong color there, I'm sorry. For the people at home. It doesn't matter. And what about for 270 degrees? It takes up 3 quadrants. How would we identify it with fractions? This is 3 quarters. And then a full turn is just 1. Okay? So this is 1. What does the direction matter when you're turning objects? Can you just turn it in one direction, or could you turn it in 2 directions? Ethan. So if we could turn in 2 directions, us, then this can turn in two directions as well. What do we call the directions? Does anyone remember? This goes way back. Will? Yeah, so we have clockwise, which we will abbreviate it to CW, and counterclockwise. And counterclockwise would be CCW. Okay. So what direction have I made the turns go now? Just on this diagram. Have I gone clockwise or have I gone counterclockwise? Irfan. It's counterclockwise because it goes in the opposite direction of a clock. Had the turns gone this way here, if we started here and went down this way, this is a quarter turn clockwise or 90 degrees clockwise. Okay.